Hello guys, today me and my friends would like to discuss with you guys about our dynamic assignment question 1 and 2. So let's check it out.
What's up guys, today I'm Hakimi. Today I want to teach you about question 1. Okay, and then we start with question 1 with sketch the free body diagram. I'm going to teach you how to sketch the free body diagram. So first, here is B and A, and this is Y not equal to 1 meter. So at this side 3.5 meter. So this ball, they have a weight. So
Hello guys, my name is Jason. Today I would like to teach you guys the solution of our dynamic equations 1b. Let's solve it together guys. Let's go. Let's look at question at B. Calculate the speed of the object just before it leaves the surface at B. Mean that we need to calculate the speed of the ball from point A travel to point B. By using the principle of work and energy to the ball and determine the speed at the B, we can use the formula of TA plus suffixation U A to B equal to TB. And then the equation can be rewrite to 1/2 times mass times velocity A square plus mgh equal to 1/2 times mass times velocity B square. Then since the questions mentioned the ball is released from the rest, we can assume velocity A is 0. So we can cancel out this part, become 0. And then since the mass are same, so we can eliminate the mass. Then the equation rewrite become like GH equal to 1/2 times velocity B 2. G is the gravity of the Earth. So gravity is 9.18 times the height at the point B, mean that we need to minus the 1 meter because it not yet live on the ground. So we use 3.5 minus 1 equal to 1/2 times BB squared. Then we solve the BB equal to 9.81 times 3.5 minus 1 times 2 square root. The velocity we get is 7.004 meter per second. And then we can assume it becomes 7 meter per second. Okay guys, do you guys understand what I explained just now? I hope you guys understand. Well done.
Hello there. Now it's my turn to solve the rest of the questions. Let's go. So hi guys, let's solve this question 1C. Okay, basically this question asks to calculate the distance from the wall of the ramp at B to where the object strikes the ground. So this question asks us to find the distance. So in order to find that, we have to list the x component and y component. So in x component we got xc equal to xb plus vb xt equal to, we know that xb is 0 plus 7.004t. So we got xc is equal to 0.004t. In y component, we got yc is equal to yb plus vbt minus 1 over 2 gt squared. Since we know that yc is -1, so we just sub it into here, and yb is equal to 0 plus vb is 0 to -1 over 2 times 9.81 times t squared. So when you solve this, you got 1 over 2 times 9.81 t squared. So you got t is equal to square root 1 over 4.905. So t is equal to 0.455. So we sub it into this, sub it in question 2 into 1. We got xc is equal to 0.004 times 0.45. The answer is 3.5 meter, 3.15 meter. Okay, the answer is 3.15 meter. Hello guys, let's look on question 1D, which is the question asks us to compute the speed at which the object hits the ground. Summation of TA is kinetic energy plus summation of internal energy from A to C equal to summation of kinetic energy at C. So we show that this equation 1 over 2 mva square plus mgh equal to 1 over 2 mvc square. So since the question mentioned the ball is released from rest, we assume VA is 0 meter per second. Now we know that this equation, we know that the mass ball is 0.6 kilogram, and we can automatically eliminate the mass, and we know that VA is equal to 0. We straight away eliminate this equation. So the remainder equation is GH and 1 over 2 VC square. So we want to find the speed at which the object hits the ground. Hits the ground means that the ball will touch the ground. This is at B, this is A, and when the ball reach the ground, this is the ground. So we want to find the speed in here, ground. Yes, this is ground. So the speed in the ground is 9.81 times 3.5 times 2 square root, and we got the answer 8.29. Hi guys, right now let's move on to question 2A. Okay, the question asks calculate the velocity of the object just after it rebounds from the ground. So basically the question asks this ball which it accelerate slide down to B, then from B the ball will move to C. When it reaches C, it will bounce back from the ground. So the question asks its velocity. The velocity cy. So in order to find that, okay, we know that this value v1 y square is equal to 0. We straight away put 0 here, and plus 2 acceleration. Acceleration means that it is negative 9.81 because it moved downwards. SCY is 0. SCY is 0 minus S1Y is here, so 1. When you perform this equation, you will got the final answer is negative 4.430 meter per second. Next, we have to apply the coefficient of restitution in y direction. So this formula, we know that E is equal to V ground 2 minus VCY2 over VCY1 minus V ground. So we sub the value in the equation. We got V ground is 0, VC1 we want to find it, and over negative 4.43, 0 minus 0. So we solve this equation, we got 3.101 meter per second. So in this question, we have to, this is question 2b. So in this question, you have to compute the maximum height to which the object rises after the first bounce. So we have to find h. Actually, before we can find h, we have to know the rebounding velocity. Okay, and when the rebounding velocity means that this is the diagram, then when the ball reach B, it will rebound back. Okay, the rebounding velocity means here at C, so this is C. So in order to find the rebounding velocity at C, we straight away put this equation. Vc2 is equal to 0.004 square plus 3.101 square root it, and we will get the answer 7.66 meter per second. Next, when we got this equation, we know that this C, the rebounding velocity at C is 7.66 meter per second. Next, we use kinematic equation to find the vertical motion after it rebounds from the ground. So the kinematic equation is Vcy square is equal to Vcy square 2 plus 2ac h, the maximum height that we are going to find, Scy is equal to, okay, first note that Vcy here is 0 automatically because the potential energy is at max and the ball is at highest. H is here, distance from the ground to the bounce, the maximum height that the ball can reach. So when the ball is at its highest position, this is automatically equal to 0. And when the ball is higher also, we know that the potential energy is at max. So Vcy2 is, we find this answer is from from question 2a. So this is 3.101 square plus 2 negative 9.81 h minus 0. So equal to h. We solve this equation, we get 0h is equal to 0.5 m. That's all. Thank you.